Quiz number 2. So the first problem, determine the loss of head due to a sudden enlargement in a pipe carrying 15 liters of water which suddenly changes from a diameter of 15 cm to 20 cm. Also find the pressure difference between points before and after of section. So ito yung figure. So the D1 and D2 and the sudden enlargement of the pipe. So the given are the discharge which is 57 liters per second, and then the diameter 1 which is 15 centimeter, and then diameter 2 which is 20 centimeter. And we know that the specific weight of water is 9.81 kilonewtons per cubic meter. So the required R is the head loss and the pressure difference between points before and after of section. So solution, first we need to find the velocity V1, which is equal to the discharge over the area given the diameter 1. So 57 over 1000, which we convert 57 liters to cubic meter. So we divide 1000 over seconds divided by the area of the diameter 1, which is equals to, velocity 1 is equals to 3.226 meter per second. And then we compute for the value of the velocity at the second diameter, which is 57 over 1000 over the area of the given the diameter number 2. So we have velocity which is 1.814 meter per second. And then after that, we will find the value of KE, which is equal to the ratio of diameter 1 over diameter 2. So we have 15 over 20, which is equal to 3/4 or 0.75. And then we will find the value of KE given that value. So we have this given 0.8 minus 0.7. These are given from the table, over 0.13 minus 0.26 is equals to 0.8 minus 0.75, which is the value, over 0.13 plus minus KE, which is the value of given KE is the value of the value from the given 0.75, the ratio. So the value is 0.195. Then we have the formula HE is equals to, so we use the formula of we use this formula in getting the value of HE, or which is equivalent to the head loss, kasi yun lang yung given head loss, no, walang ibang factor. So we assume that HE is equals to HL, so which is equivalent to KE multiplied by the velocity 1 squared over 2 times gravity. So substituting the value 0.195 multiplied by 3.226 squared over 2 times 9.81. So we have the head loss, which is equivalent to 0.103. So we have the value for the first required given, which is head loss. And then next we will find the value of the pressure difference before and after of section. So we have the given formula. So V1 squared over 2 times gravity plus the head loss ay pressure head plus Z1, which is equal to 0 kasi the pipe is in a level surface. So walang grade, or yes, walang grade. It's equal to the velocity squared over 2 times gravity plus the pressure head plus Z2, which is equivalent to 0 plus the head loss. So simplifying the equation, we'll have the change in pressure is equals to P1 over P2 over the specific weight of water, which is equal to velocity 2 squared minus V1 V1 squared over 2 times gravity. So, yun. Plus HL. So, we have substituting the values. Change in pressure is equals to 1.814 squared minus 3.226 squared over 2 times 9.81 plus the pressure head, which is equal to 0.103 multiply the specific weight of water kasi yan. Multiply natin doon. So we have the value of change in pressure, which is equivalent to negative 2.542 kilopascal. So that's the answer for change in pressure. And then number 2 problem. An oil with density of 900 kilogram over cubic meter and the kinematic viscosity, which is equal to 0.0002 meter squared per second, flows upward through a 10-meter long pipe segment inclined at 40 degrees with the horizontal. The pressures at the upstream and downstream end of the pipe are 350 kilopascal and 250 kilopascal respectively. The diameter of the pipe is 60 mm. Assume the flow is laminar. So the given are the RE, which is the Reynolds number. So laminar. So we have the value 2000. And then the density, which is equal to 900 kilogram per cubic meter. And then the kinematic viscosity, which is 0.0002 meter squared over seconds per second. The length, which is equivalent to 10 meters. And then the grade or the angle kasi inclined yung pipe natin. So for 40 degrees. So the solution and the required are the head loss and the velocity of flow and then the Reynolds number. So we have our solution. First, we need to find the value of F given the value of 2000. So given the formula 64 over Reynolds number is equivalent to 64 over 2000. So we have the value of F which is equivalent to 0.032. And then substituting the values of RE, we can find the value of the velocity. So 2000 is equal to the velocity multiplied by the diameter, which is 60 over 1000. So we need to convert 60 mm to meter. So we divide it by 1000 over 0.002. So we have the value of velocity 6.667 meter per second. And then given the values of V, we can find the value of the discharge Q. So we have the area times the velocity, and given the value of the diameter, which is 60, we can find the value of the discharge, and the value is 0.019 cubic meter per second. And then yun. So using the Darcy-Weisbach formula, so we have the value of F, so we can use and we can utilize the value of F in finding the value of the head loss. So head loss equals to 0.0826 multiplied by F times the length times the discharge squared over the diameter raised to 5. So substituting the values, 0.0826 times 0.032 times 10 times 0.019 squared over 60 over 1000 raised to 5. So we have the value of HL, which is equivalent to 12.271 meters. So we have number 3 problem. A pump draws water from reservoir A and lifts it to reservoir B. The loss of head from A to section 1 is 3 times the velocity head in the 15 centimeter pipe, and the loss of head from section 2 to B is 20 times the velocity head in 10 centimeter pipe. Compute the power input of the pump assuming it operates at 80% efficiency. So we have the figure here. We have the figure here. So the first reservoir, which is in A, which has an elevation of 0, and elevation the reservoir B, and has an elevation of 80 meters. So, yun. So, the water goes from A and then all the way to the pump, and then from the pump all the way to the reservoir B, which has an elevation of 80 meters. So, at pipe number 2, we have the head loss, which is equivalent to 20 times the pressure head, the velocity head. And then at pipe 1, we have the velocity velocity head 3 times. So we have our solution. So first we need to find the value of velocity 1 and velocity 2, which is equal to discharge over area, which we need to first to find the value of the discharge. We will convert the discharge to cubic meter cube, so that's why we divide it by 1000. So we divide it by the area. We have the velocity 1, which is 0.849 meter per second. Then next, the velocity 2, which is equivalent to the discharge over the area 2, given the diameter at pipe number 2. So we have 15 over 1000 over the area of 2, which we have velocity squared, velocity 2 is equivalent to 1.91 meter per second. So after we have the value for the velocity, we have our equation given the formula. So VA, kasi we need to find the equation, the relation of from A to B. So from the elevation A to B, we will have the value of the head loss from in this entire system or figure. So we have, so at the velocity head at point A, we have 0 kasi at A there's no movement of water, walang flow. The same through B, we have no flow of water kasi stagnant. And then pressure head at A 0 kasi open surface, so yung pressure natin is 0, so mag 0 yon. The same through sa pressure at B, so makakancel yan 0. So plus ZA kasi meron tayong difference in elevation, plus HA is equivalent to ZB plus HLA to B. So we need to find the value for HLA. So given the values of ZA and ZB, kailangan natin is the value of HA and HLA, HL, head loss from A to B. So we have, simplifying the given formula, we have head loss from A to B is equivalent to HL, head loss from A to 1, which is yon, yung head loss dito, and then the plus head loss from point 2 to B. So we have substituting the values kasi meron tayo yung values ng the velocity head at pipe 1 pipe 1 kasi and pipe 2 kasi magkaiba yung diameter nila. So we have substituting the values, 3 times 0.849 squared over 2 times 9.81 plus 20 times 1.91 squared over 2 times the value of the gravity. So we have H head loss from A to B is equivalent to 3.829 meters. So inad lang natin yun. So ayan yan. And then substituting again the values given yung formula rito dito sa taas. So we have nakuha natin yung value ng HL head loss natin from A to B. So kailangan natin hanapin yung value ng HA. So we have HA is equivalent to 0.80 plus 3.829. So nakuha natin yung 80 by the value, yon, elevation at B, ZB. So elevation at ZB is 80. So yung ZA natin is 0 kasi yung elevation at A is 0. So yun, cancel out dito, yung 0 yun. So we have 80 plus 3.829, we have the value of HA, which is equivalent to 83.829 meter. So yung HA natin, the value we will have the value for E. Kasi mag-equal yun. So, substituting the this given to the formula of PO, which is equivalent to the discharge times the specific weight of the fluid times the value of E. So, substituting the values, we have the discharge 15 over 1000 multiplied by 9.81 times 83.829, which is the value for E. So, we have 12.335 kilonewton times meter per second, or 12.335 kilowatts. So, we have the value of the power we have. And then, given also the required, the power input, which as the formula of PI is the power over the pump efficiency. So we have the given of power, given the value of PO, which is equivalent to 12.335 kilowatts, we divide it by 0.80 kasi the given pump efficiency is 80%. So we'll have the value of the power input, which is equivalent to 15.419 kilowatts. So that's the value of our PI. Yeah. That's all.